In this video we're going to show that sine A plus B equals sine A multiplied by cos B plus cos A multiplied by sine B. It's very similar to the video that we showed that cos A plus B equals cos A cos B minus sine A sine B. Okay? Very similar in how we set it up. So the first thing we do, like in the video that we used to prove that, was we draw a right angle triangle. And we call this angle A. A right angle, and then we'll draw another right angle triangle up like this. We call this angle B. We will call this O. We call this say, Q. We call this maybe C. We call this N. Okay. So then what I'm going to do is, like the last one, I am going to draw a perpendicular from C, perpendicular to QO, and we'll call that, I don't know, maybe M, I suppose. And we'll draw a line across, straight across from N to where it meets CM. We'll call that R. Okay. Right, and like the last video, if this is A, well then this will also be A, and seeing as that's a right angle triangle, that would be A, sorry, that would be 90 minus A, and based on that, then this will be A also. Okay, so let's get into our proof. The first thing we can say is that sine A plus B equals, right, and we're going to concentrate on this triangle, okay, because that's sine A plus B, and sine, we'll just write the trigonometric ratios, could hungry stupid ostrich have taken over America. We can see from that sine is O over H. So sine AB would be O over H if we label our triangles in relation to this angle here, A plus B. The O will be here, the A will be here, the H will be here. So sine A plus B equals, what H is side OC and O is side MC. But we can rewrite that sine A plus B, and if we look at CM, that line, well, we can actually say that that is MR plus CR. Okay, so we're going to rewrite CM CR plus RM. So that equals CR plus RM, and that would be over OM. Sorry, OC. OC. Put the plus in the middle. So, like when we were proving that cos A plus B equals cos A multiplied by cos B minus sine A multiplied by sine B, we'll rewrite this. So, again, we'll just put a line there to show we're kind of finished with it. And we will say sine A plus B equals sine A cos B minus cos A sin B. Alright, so now we have to look at our triangles again. So we're looking for sine A. So sine A would be this triangle, because we're talking about angle A. And we'll get rid of these. Now in relation to that triangle, that would be the opposite, that would be the adjacent, that would be the hypotenuse. So sine A plus B equals, what's sine A? Sine, as we said, is opposite, this one, over hypotenuse, which will be NQ over ON. Okay, so next we look at the cos of B. So we look at this triangle. We label it O, A, and H. And cos is adjacent over hypotenuse. So we'll be multiplying it by, the adjacent is ON, and the hypotenuse is CO. Okay, we have a minus in our formula, and now we're looking for the cos of A. So forget about this triangle. So next up we're looking for the cos of A, but this time we're going to look at this triangle, okay, because we have the cos of A here. Right, and you just need to learn that, okay? If you practice it a few times, you'll remember. So with relation to this triangle, just tidy up around here. In relation to this triangle, well, this is the opposite. Here. The hypotenuse is here, the adjacent is here. So we're looking for the cos of A, and cos is adjacent over hypotenuse, and the adjacent is CR. And the hypotenuse is CN. Multiplied by, and we're looking for the sine of B, so we're back to this triangle again. This one. I'll label the sides, I'll rub out these ones, label the sides again, so this is O, O, A, and H. And it's the sine of B, and sine is O over H, so O is Cn, and H is OC. Okay, I just remembered there, or just realised that I've said a minus instead of a plus, okay, so it's actually a plus. Right, so what I've done, if you remember back on this, okay, I've shown that sine of A plus B is that. I've worked it all out to be that. I've then taken sine A plus B equals sine A cos B plus cos A sine B, and I have shown that to be this. Now all I have to do now is take this, and if I can show that that is the same as that, well then I've shown that this is true. Alright? Just again, very similar to how I work this. Right, so let's go. Take this first. Well, the ON can cancel out, so we're left with sine of A plus B equals NQ over ON, or sorry, CO, plus, and these cancel out, CNs, so I'll be left with CR over OC. They're not quite identical yet. The CR and the OC bit is identical to this, but here I have RN and OC, and here I have NQ and CO or OC. Okay, so CO and OC is the same, so that's fine. It's the top bit, right, the numerator, that's different. In the top one I have RM here. In this one I have NQ. But let's see. RM is this. and Q is this. Are they the same length? Yeah, they sure are. So I can write over here Rn equals NQ. So then I can say therefore sine A plus B equals Rn over CO or OC, whichever I want, it doesn't matter, plus CR over OC. Now, that is the same as that. So I can say therefore sine A plus B equals sine A cos B plus cos A sine B. Okay, so as I said, it's very similar to how we did that. Okay, thanks guys.